Assalamu alaikum. I am Mohammad Mahinur Rahman from Bangladesh University of Engineering and Technology. I will be presenting you my paper, Solar Energy Based Net Meter DC Bike Charging Station in Bangladesh. Our whole presentation is divided into six different parts. The first, background, proposed system architecture, design of rooftop PV system, system modeling in PV system, cost analysis, environmental impact, and conclusion. So the background of our work is based on the increasing number of easy bikes in Bangladesh. They are really posing a great threat into the electrical distribution system in Bangladesh and also the electrical consumption in Bangladesh. With each easy bike consuming 12 units of electricity, a total of 10 million easy bikes would consume a huge amount of electricity. So the number of easy bike charging stations are also increased due to the increasing number of easy bikes. So the government of Bangladesh has also taken initiatives to implement solar charging easy bike charging stations, so PV based easy bike charging stations, which are mainly battery energy storage system based, but they are becoming now ineffective due to the high maintenance and operation cost of battery energy storage systems. In our paper, we have used the net metering guidelines 2018 to design a net metering based easy bike charging stations that is solar powered. Here, in a net metering based charging station, the grid can be used as a virtual battery. So it is a very big advantage over the high cost battery energy storage system. So moving into the proposed system architecture, we have taken a typical easy bike charging station that is situated in Khulna metropolitan city, and in our design we have the capacity to charge 30 easy bikes simultaneously. Figure 1 shows the proposed system block diagram. In the moving into the design of the rooftop PV system, our rooftop PV system is designed based on the net metering guidelines established by SREDA. So we have used 350 watt peak half cell monocrystalline solar panels manufactured by JA Solar with an efficiency of 20.8%. The grid tied inverter that we have used have a three-phase SMS Anitri power, which have a output capacity of 15 kilowatt and a maximum efficiency of 98.2%. It is also to note that each inverter has two maximum power point trackers present with an operating voltage of 360 to 800 volts. Figure 2 in this slide shows the schematic diagram of the proposed rooftop PV system. So according to the net metering guidelines, the PV system size can be 70% of the sanctioned loads, which stands at 30 kilowatt. So we'd be needing two 15 kilowatt inverters, and using a DC to AC ratio of 1.2, the nominal power of the PV system is 36 kilowatt peak. And using 350 watt peak for the 36 kilowatt peak PV system, we would be needing 104 panels. So the 104 panels are arranged in 8 strings with 13 panels in each string. In each MPPT input of each inverter, two strings are connected. Also, a bidirectional energy meter is installed between the MDB and the grid for net metering. Also, other components that are used in the net metering system design, the whole PV system design, are includes double insulation, ultraviolet ray protection wires, XLPE wires of different appropriate diameters, and also circuit breakers of appropriate diameters at different junction boards and also distribution boards. Sufficient such protection devices are the and protection components are selected for the design according to IEEE standards. Now, moving into the PV system modeling in PVSYST, figure 3 shows the solar power diagram of the selected project site in Khulna, and figure 4 shows the loss diagram. Our whole PVSYST modeling is done in PVSYST 7.1, and the modeling is done for 8 different azimuth orientations: north, south, northeast, northwest, east, west, southeast, and southwest. A tilt angle of 7 degrees has been used in our simulations, and since our typical easy bike charging station is south faced, so in all our calculations we are using the values obtained from south azimuth orientation simulation, where the daily energy generation can be found as 154 units, and for annual it's 56,290 units. And it is the highest energy yield among all the azimuth orientations. The performance ratio for all the azimuth orientations has an average value of 82.58%, and each of them are very close to each other. So according to simulation, the area of the PV system model comes as 175 meters square, which is very much sufficient for the charging station, which has more than 300 meters square space. So a scheduling system can also be introduced to ensure that easy bikes are charged in a disciplined manner, and not more than 30 easy bikes are charged in each phase when operating in uh, full capacity. And also the easy bikes are charged after 9:30 p.m. to reduce peak load. This results in lower losses of utility transformers and also improve power quality. Figures 5 and 6 shows the normalized energy productions and the comparison of PV energy productions for 8 different orientations respectively. So moving into the system cost analysis, since we are talking about two different scenarios of easy bike charging stations, the grid connected PV based easy bike charging station with battery energy storage, and which is method A. And for method B, we are considering the grid connected PV based easy bike charging stations with net metering, but without battery energy storage system. So we have found established cost structure, and we have used the scaled out version of that. And the revenue system is that for easy bike charging, BDT 130 would be used each day for each easy bike full charge, and for 30 easy bikes, our revenue of 14 lakh 23,000 will be generated each year. And each easy bike consumes 12 units of electricity each, so the whole consumption is uh, 360 units daily. um, in our calculations, we have consumed south azimuth orientation. In table 1, we can see the comparison of financial analysis for method A and method B for the 36.4 kilowatt peak PV system. For moving into the analysis of method A, flooded lead acid battery banks are used, which has a 75.6% efficiency. So out of the 154 units of solar energy that has been generated, we can only store 117 units. The batteries have to be replaced at 8 year, having a warranty of 5 years. And considering about the initial project cost is 167 BDT per watt peak, where the total cost contribution comes from 50% grant, 35% soft loan, and 50% from owner's equity. The soft loan is provided by ITCOL, and the grant is provided to reduce the payback period due to the high operation maintenance and also installation cost of the battery energy storage system. Despite being this, the payback period of method A is 111 months, which is a very high amount. We will see further. Uh, at the end of 20 years, considering a financial plan for 20 years, there is a huge cumulative cash flow, but also huge expenses sustained because mainly of the battery energy storage system. In method B, where we eliminated the battery energy storage system and included the net metering, the EPC cost, engineering and procurement cost, is BDT 62 per watt peak. The financial structure of this system is 75% loan and 25% owner's equity. Um, and in this process, we see that the payback period is 45 months, which is much, much less than 111 months. And another thing is that all 154 units of the solar energy generated can be utilized. The rest 206 units of the total energy demand is consumed from the grid. In the net metering system, what we are observing is that in during the daytime, 154 units of solar energy generated are being supplied to the grid, and at the night 360 units are being consumed from the grid, but a net usage of 206 units are being built for the net metering system. That is the advantage of net metering. So using the tariff rate of DPDC, which is 9.55 per unit, we can see that using a net metering, a charging station can save around 535 million 5 lakh 36,806 BDT annually, which is around 24% of the initial project investment. So the expensive battery bank is eliminated. We are saving a huge amount of utility bills and also using the grid as the virtual battery. Also, we can observe that the revenue generated is almost equal to the owner's equity. So from year one, the owner's equity can be almost paid off. And this cost will further reduce since the cost related to solar energy generation is reducing in recent days. And the benefit is that the low profit margin for PV system with BESS is compared to the net metering is due to the battery energy storage system. Similar cost analysis were carried out for other 7 orientations, and table 2 represents that the payback period for both method A and method B for 8 different orientations. And figure 7 shows the cumulative cash flow diagram, where we see The payback periods 111 months and 45 months clearly for method A and method B. Now, moving into the environmental impact and conclusion, in a PV system with battery energy storage system, PV modules and the batteries are the most GHG intensive components. And considering the well to wheel value for typical PV system in Bangladesh, and also the grid emission factor of 670 kg carbon dioxide equivalent, we can see that the PV system with battery energy storage system has 35% more emissions than a proposed PV system with net metering. So the use of rooftop PV system with net metering eliminates the use of battery energy storage system. This system is more environmentally friendly. Table 3 shows the comparison of GHG emissions for method A and method B, and we have shown here for the south azimuth orientations. Also, another problem is the disposal of battery and e-waste, which are hazardous to public health. So, presence of specific guidelines are necessary. So, concluding our whole presentation, we have designed a 30 kilowatt solar power charging station, easy bike charging station with net metering, and we have emphasized the advantage of net metering over PV system with battery energy storage system. Simulation of a PV system design carried out in PVC 7.1 to understand feasibility has been shown. We have also shown the cost analysis between PV systems with battery energy storage and net metering, and also the system design has the potential to lower GHG emissions by 35% if a PV system with net metering is used instead of a battery energy storage system. So that's all from my presentations. Thank you very much. If you have any questions, please let me know.